Yes. Oh, I say that, guys, if you are not hearing me, let me know. Ne? Let me know. I hope you are hearing me. Ne? Yes, we are saying that the carbon atom with a functional group, if there is any challenge, please let me know in the comment section, ne? So that I can sort it out. Ne? Yes. So we are saying that tertiary alcohol, the carbon atom with a functional group is attached to other 3 carbon atoms. Please don't go to the paper without knowing that. Ne? Don't go to the paper without knowing that. Gift, are we in together? Ne? Yes. So when you go to the paper, make sure that you know that primary alcohols, secondary alcohol, and tertiary alcohols, you have to know them. The carbon atom, how do you differentiate them? We say that primary alcohol, the carbon atom with the functional group is attached to 1 carbon atom. Check the functional group. Carbon atom having a functional group is attached to 1 alkyl group. Yes, that's perfect. The secondary alcohol, the carbon atom with the functional group is attached to other carbon atom. This is the first one and this is the second one. Then the tertiary alcohol, the carbon atom with the functional group, if this is the carbon atom with the functional group, is attached to other 3 carbon atoms. Ne? Please, you have to know that. You have to know that. Then, saturated and unsaturated. Saturated and unsaturated compounds. Yes. So, how do I differentiate the two? Saturated compounds are compounds which have single bond between the carbon atoms. Single bond throughout between the carbon atoms. Guys, make sure that you know this. Make sure that you know this. What about unsaturated compounds? These are carbon atoms. These are compounds which have single or triple bond. Did I say single? Double or triple bond between carbon atoms. Don't say double or triple bond without saying between 2 carbon atoms. Between 2 carbon atoms, at least there must be, because if it's like this, and then you have is a ketone, but is single bond throughout. This compound is a saturated compound, but it has a double bond somewhere. Therefore, it's a saturated compound, but the double bond is not between carbon atoms. So unsaturated compounds, they have double or triple bond. Don't stop there. You have to say that between 2 carbon atoms. I think I'm clear there. Then, how do I differentiate between a saturated compound and unsaturated compound? What they do is, we will bring bromine water. And then we say that compound A, and you have compound B. And then we say that compound A will decolorize. Don't forget that bromine water is red. Is it clear? So compound A decolorizes bromine water, while compound B cannot decolorize bromine water. Then they ask you a question that which one is a saturated compound, which one is an unsaturated compound, meaning that this one decolorises, meaning that it changes the color into from red to colorless, while this one, it doesn't do so. It means that the answer is, if a compound is unsaturated, it has a double bond somewhere, this double bond is going to break so that the bromide comes here and another bromide comes there. So that now the bromine has been used. The red color has been changed into colorless. So you need to know that. Ne? You need to know that. So now here, when it comes to here, what you need to look at, the double bond will not, because there is no double bond, so the bromine water will not be decolonized. So guys, make sure that you know that technique. I have so many questions I can show you regarding to this, but just I'm trying to do a highlight, and then we can go through 2-3 questions, and then yeah. Then another question you cannot go without knowing is the polymers. The polymers. Did I say polymers? Not polymers. The isomers. isomers. We have different types of isomers. But guys, take note of this. To identify the type of isomer, or to if they ask you to define a specific type of isomer, if it is a chain isomer, you know that these molecules, they have the same molecular formula, but different. If it is chain, different chains. The arrangement of the substituents, you understand, is different. For example, 1, 2, 3, 4. Yes. So chain and structure looks the same. 1, 2, 3, 4. Now this is a chain. So if I change this 1, 2, 3, and then I put the carbon atom there, you see, don't forget that I'm not putting every single hydrogen atoms in there. You understand? Just because of time. So guys, now because this is straight and then this is branched, then it becomes a structure isomer, meaning that is a chain isomer, meaning that this and this, they have the same number of atoms but different structure. Now if it is position isomer, the major difference is position isomer, yes, we are talking about the position of the functional group, but this position does not change the functional group. This is what I mean. You have primary alcohol, yes, primary alcohol, secondary, and then tertiary. To change this from primary to secondary to tertiary, in most cases, look, let me show you. 1, 2, 3, 4. The alcohol is here. So if I change this and I say 1, 2, 3, 4, I put the alcohol here. So now here I've changed the position of the functional group. Therefore, it becomes positional isomer. But now 1, 2, 3, 4. 1, 2, 3. I put the, and then I leave that there. So this one is from here to here. It is chain isomer. The functional group is still on carbon atom number 1. Carbon atom number 1. But the structure has been changed, so it becomes the chain isomer. While here, the functional group has been changed the position. Therefore, this one becomes positional isomer. And then if I have 1, 2, 3, and then I put it here, and then I put it here like that, what is going to happen to this? If I compare this with this, it becomes positional isomer. If I compare this with this, it becomes positional isomer. You understand? Someone is asking me to do polymers. No. We don't have polymers. We don't have polymers in the paper. Yeah, we don't have polymers. So don't stress with the polymers. Polymerization, yes. So this, if I compare this with this, it's 1, 2. It's 1, 2. You see? So this and this, they are non-positional isomers, because the functional group is on carbon atom number 2. If I count from this side, even if it's this side, even if this side is, but if I count from this side, 1, 2, you understand? So it's still on carbon atom number 2. You understand? So this and this is positional isomer. So guys, did I say position? Structure isomer or chain isomer, because I've changed this and then I put it here. You understand? So please, when they ask you position isomer, structure or chain isomer, and then functional isomer, please make sure that you know that. Functional isomer comes in ketones and the aldehydes, and also carboxylic acids and esters. That's all. There's nothing we're gonna bring regarding to something else other than that. So you have 1, 2, 3, and then you have an aldehyde here. Yes, you have an aldehyde there. Yes. Now, if I change this 1, 2, 3, I put it here, so it comes from an aldehyde to a keton. You see? So it means that now it has changed the position of the functional group, and then the moment it changed the functional group from aldehyde to ketones. You see? So definitely now this, because it has changed the function, then it becomes functional isomer. I think I'm clear there. So guys, please make sure that when you go there, you know this. You know this what I've said. Lastly, on this, before I go to the reactions, is only one thing you're gonna find. You understand? When it is only and only esters which has a completely different naming. For example, if I have a reaction, so now I might combine this with the reactions. Ne? If I have a reaction, you have an acid, yes, and then which is organic acid, and then plus alcohol, then in presence of sulfuric acid, you form an ester. Cool. For example, carboxylic acid, you have maybe ethanoic acid, then plus an alcohol, maybe propan 2-ol. Let me say propan 1-ol. Yes. So yes, and then this. So I form an ester. So here, the one where the carboxylic acid is coming from is the one which is going to become the main chain. You understand? Here, we don't mind about how many carbon atoms does alcohol has. No, still the carboxylic acid will become the main chain. For example, if you draw this and write it, it's going to have 1, 2. Okay, no. Let me just start with the carboxylic acid. 1. You have, yeah, like that. Is that, ne? That is this. Cool. Then this is gonna be, in most cases we reverse it, ne? So I start with the, okay, even if I don't reverse, because sometimes it confuses students, so let me just say CH3, CH2, and then alcohol here. Cool. Did I say that? Let me check. Yes, 1, 2, 3, 4. Cool. Yes, 1, 2, 3, 4. Cool. Then sulfuric acid is reacting there. They're saying question 4, sir. Which question 4? Did you say question 4? Did you see here question 4? You mean this? I don't know. Okay, please be specific, you know? Question 4. I'm going to go through everything. So now here, look guys. If you look at it here, you'll find out that this carboxylic acid will lose this, while alcohol will lose that. Then it forms water. By losing water, we call it condensation. So now I combine this with this. So this one becomes the main chain. Or the carbon atom which has oxygen double bond, it is where the carboxylic acid came from. You see now this one, the oxygen doesn't have a double bond. So now if I write the ester here, this is what I mean. 1, 2, carbon atom, double bond. Then I reverse this. Ne? So I'm going to write the oxygen there. I'm going to write the oxygen there. I've written the oxygen there. Then now I extend it to this. Then I write this. Then I write this. So basically, it's going to be like that. Please don't forget to put the hydrogens. Ne? Yes. The hydrogen 1, 2, 3, 4. Yeah, so that's how it looks like. But now, this is where that one comes from. While this becomes the alcohol, and then this becomes the carboxylic acid, because we have this part. So how do we name it? We have to say that 1, 2. So it is the propanoate. So no, it's ethanoate. 2 is eth. Don't forget I say that. You write ether. no, wait. You go up to this point, ne? Yes. Ethano, wait. But now you have this side group. Remember, once you add YL, it means that this is a side group. 1, 2, 3. So it is 3 of them. So it's prop, and then I add YL, propyl ethanoate. So guys, that's how you're supposed to name it, the carboxylic acid and the esters. So don't make a mistake. Why do we use carboxylic acid? Sorry. Why do we use sulfuric acid? Sulfuric acid is acting as a catalyst. Ne? Yes, it's acting as a what? A catalyst in this process called esterification. We can call it esterification, we can call it condensation. Still the same thing. So guys, I think the 20 marks here, you have got them. Anything related to this, you will be able to answer. You see this question? This is the question I was talking about. The bromine water has been added. So guys, make sure that you know. Ne? Yes. Please don't go to the paper without knowing that. Don't go to the paper without knowing how to differentiate between, sir, when naming esters, don't we write alcohol first? Oh, yeah, yes, I did write. Dineo, yes, I wrote alcohol first. Yeah, it's propyl. Remember, it's the alcohol here. Yes, it's the alcohol here, propyl. So, and then the main chain must be the end. Ne? Yes. Dineo, I think I've answered your question. Yes. Tabang, I didn't understand your question. Ne? Yes. And then FX, Mr. FX, we don't do polymers. Yes. Zintle, yes, grade 11, we will sort it out after this class. Then I can also do you a simple prediction so that you don't mess up. I don't know when you are writing, but still, and which province, I don't know, but still when I do it, it will cover you so that at least you focus on those things I talked about, but we will sort you out. Okay, let's go to the second section now. The second section is the reactions. Reactions. What do you look at when it comes to the reactions? Let me show you here. I'm just having simple questions. If you want this booklet is there, né? But I'm not interested in each and every question which is here. I'm just interested in a few questions. You see, what is the positional isomer? Same structure formula, but different position of the functional group or the substituents. Simple. Yes. So make sure that you know. Once they ask you that, it's easy. Primary, secondary, tertiary alcohol, give a reason, you know. If it is primary, it has one carbon atom attached to the carbon atom with the functional group. Is secondary, it has 2 carbon atoms attached to the if it is primary, it has 1 carbon atom, ne? 1 carbon atom attached to the carbon atom with the functional group. Yes. If it is secondary, it has 2 carbon atoms attached to the carbon atom with the functional group. Don't say it has 2 carbon atoms attached to a carbon atom. Just like that. Carbon atom with a functional group has 2 other carbon atoms attached to it. You understand? Please complete the statement, or otherwise you will lose it. You will lose it. Okay. Naming, we are done with it. Make sure that you do what I've said. Let's go to reactions. Ne? Reactions. When it comes to the reaction, okay, this is properties. Ne? Okay, let me go to properties before I go to the reaction. Guys, when it comes to properties, these marks you must get them. These marks you must get them. Properties is easy. You need to know straight chain versus branched chain. Ne? Then you need to know functional group. Maybe that, and then a double bond. Ne? You need to know, and then maybe is, and then a carboxylic acid. Let me say a carboxylic acid there. Then you need to know is 1, 2, 3, 1, 2. The number of carbon atoms. Do you understand? So now, know which type of forces which are found in what. If it is carbon atom, like alkanes, they have London forces. Then when it goes to alcohol, it has the London forces and the hydrogen bonds. When it goes to haloalkane, and the haloalkane, yes, it has London forces and dipole forces. When it goes to ketones, it has London forces and dipole forces. When it goes to esters, it has dipole forces and London forces. When it goes to carboxylic acid, it has the London forces, hydrogen bonds, and dipole forces. So now dipole forces are stronger than London forces, while hydrogen bonds are stronger than London forces and dipole forces. So you need to know that. So now if let me just give you an example here. Let's just get one simple question. What is boiling point? You have to know that. Remember that it's the temperature at which the vapor pressure, or when the vapor pressure is of this liquid is equal to the atmospheric pressure. That's when the point at which, that's the boil, because they're saying boiling point. They're not asking you what is boiling. Boiling point. When they say boiling, the process then when the vapor pressure is equal to atmospheric pressure. Cool. But when they say boiling point, then you say is a point at which, yeah, please make sure that you differentiate that. Then look at this. You have butanol, pentanol, and hexanol. All of them are straight chain, for example. Which one is going to have a higher boiling point? Definitely, we shall see that hexanol has a higher boiling point compared to this. Why? Because of the number of carbon atoms. This one has, if it has 3, this one has 2, this one is going to have a higher boiling point compared to this. Do you understand? Yes. So, you know that. Then if it is a functional group, let me see if there is one with different functional group. Saturated and unsaturated, okay. Define what's boiling point. Yeah, let's look at this. Then this one is methanol. Methanol is, all of them are is the same thing, is alcohol. But what is different here is still the number of carbon atoms. If it is alcohol versus alkane, definitely alcohol is going to have a higher boiling point, because alcohols, they have London force, yes, and then they also have hydrogen bonds. So it means that it's going to have a higher boiling point compared to this. So if it has London force, if it has dipole, so the one which has dipole will have a higher boiling point compared to the London force only. The one which has hydrogen bonds will have a higher boiling point compared to the dipole force and the London forces. Please make sure you know that. How does the vapor pressure versus vapor pressure versus the boiling point? So when we talk about the higher the vapor pressure, the lower the boiling point. You understand? You must know that. But now, if I have a compound like this, okay, compound like this, yes, this compound has a lower boiling point. This one has a higher boiling point. So this one is going to have a higher, it's going to have a lower vapor pressure. It's going to have a lower vapor pressure. Yes, it's going to have a what? A lower vapor pressure. This one is going to have a higher vapor vapor pressure, while this one is going to have a lower vapor pressure. Why? Because the higher the boiling point, the lower the vapor pressure. Why? Because it's going to form low vapor. Why? Because it will require a high amount of heat to break the intermolecular forces of attraction. If it is London force, or if it is dipole forces, or if it is hydrogen bonds. For in this case, because it is an alkyl, it has the London force and the hydrogen bonds. So it requires high energy to break those intermolecular forces of attraction. Therefore, it forms a lower vapor pressure. You understand? Yeah, well, this one is still does have the same type of bonds, but this one has a higher number of carbon atoms. So the London forces are much greater than what is in butane 1-ol. You understand? And then it's gonna require lower temperature or lower heat to break those bonds. Hence, the boiling point is gonna be lower, and the vapor pressure is gonna be a little bit higher. So I think I'm done with that, unless you have any question. Then when you go to yes, all this is showing you the same thing. Yeah, the reactions. Just a moment. Yeah, someone is Cindy. Please do question that asks the calculation of the empirical formula. Usually give us mass and the hydrogen. Yeah, okay. And this one is asking me to do a simple question which involves the empirical formula, and this question, let's look at question. Okay, I'm going to go there. Just let me just give you a simple highlight here. But empirical formula, please. Okay, sharp. Let me give you a highlight here. Question. Okay, I don't see. But okay, let me just design my question. Let me just design my question so that you see. Okay. For example, they can say that the questions are in there in that booklet, but I can't spot them out now. All right. They are saying that you have. This is just an illustration, because to get it perfectly, you have to first sit down and then calculate and find out if it is working out. Okay, you have this compound, and then they want you to find out the molecular formula. For example, okay, I'm just gonna give you I'll show you. So if this is the molecular mass is 200, just giving you 200. So now they want you to find out and then they say that this is 10%, and then this is 5%, and then this is what percentage is this? 10, 50. It's too small. Let me just say this is 40%, and then this is 10%, and then this is 50%. So how do I do the empirical formula here? You start with the elements. You have carbon, hydrogen, and oxygen. Then you tell us the molecular mass, the atomic mass for each. You have atomic mass, so of each. This carbon is 12. You look into the periodic table. Then this one is 1, and then this is okay. No. There's something which yes. Let's start with the mass. Mass here in this case they have given it in percentages. So this is 40%, this is 10%, and then this is 50%. Then atomic mass. You look into the periodic table. So it is gonna be 12. It's gonna be 1, and then it's gonna be 16. So now you divide the mass over molecular mass or atomic mass. Yes. In this case, you get the number of moles in actual sense. So you're gonna say 40 divided by 12, then 10 divided by 1, and then 50 divided by 16. So now after that, you get the answer here. So you calculate, guys. I'm just giving you a rough estimate. You calculate. I'm not calculating. Yeah, because someone asked a question. So I'm just rushing it. So if you divide here, maybe 32, 24, maybe it goes there three times. Let me just say 3 times. And then here it goes 3.5. Okay, let me just say 3.5. And then here it's 10. And then here is gonna be if you divide, maybe it's also gonna be 3.5. I'm just giving. Yes, I'm just giving. I don't know. So you divide by the smallest, 3.5. 3.5. You see? Here you divide by the smallest. Here you get 1. Here you're gonna get maybe 3 or 2.7. Yeah, maybe you're gonna get 2.9 or 2.8, whatever. And then here is gonna be 1. You understand? So now after that, you say that this is approximately 1, this is approximately 3, and then this is approximately 1. So now you have to substitute here, and then you say that C is 1, H there are 3, and then oxygen is also 1. So that's done. But if they ask you the molecular formula, because that is the empirical formula, this is the empirical formula of that structure. But if they ask you the molecular formula, then you have to equate it to the molecular mass. They give you the molecular mass as 200. 200. So you say 200. Yes, is equal to 200. Then you come here, you tell us that you put it in bracket. You say maybe X or N, whatever you put. So it's gonna be this one is 12 plus 1 times 3. Yes, then plus 16. 16 times 1, because it's 1. All of it is gonna be in the bracket of this number you have, so that we need to find out what is X. This is equivalent to 200. So this is 18 is 8 is 28 plus 3, that is 31. Yes, isn't it? Sharp. Is equal to 31x is equal to 200. Then you divide by 31, you divide by 31. Look for the answer. You look for the answer. So the X you find, I'm not saying that it's not actual answer. I'm just giving a rough estimate so that we are rushing, so that we cover other subtopics. So here it is 200. 200, what does it mean? So here I get maybe X is equal to, maybe, let me just say X is equal to 5. I'm just giving an example. X is equal to what? 5. So if I come here, I come back here, and then I substitute it here, because we said X is equal to 5. So I'm gonna say C times X, which is X is 5. It is 5 carbons. And then here hydrogen is 3, but times X, which is 15, and then oxygen is gonna be also 5. And then the empirical formula, the molecular formula is also done. Sharp. So guys, I'll only talk about something when I've reached that topic, that subtopic. Yes. Can you please talk about the remitting reagents? Okay. Now I'm going to change from the prediction to a full what? A full discussion. You would have requested for a full discussion. Yeah, that's it. Okay, but I think now you are covered. Who is this? Who is this? Percentage yield, Mac. Okay, sharp. I'll talk about it. And then I think you are covered. 1K. Yes. Let's go to the next question. Reactions. Yeah, we are talking about these reactions. Yes. So guys, these reactions are simple. You know why they are simple? When they bring a question, you have to know how to manipulate them. You have to know how to manipulate these what? These reactions. Yes. How do you manipulate them? Okay, let's start. Do I still have more papers here? Let me just clean up. Okay, Cindy. All right. So you are covered. All right. Reactions. When you look at, guys, these reactions, they are simple to understand. Number one, there are some things which don't requires any catalyst. There's something reactions which require catalyst. There you have to know that when it is when do I apply water on the reaction? You understand? And then when is water being lost? When do I use a strong base? When do I use an acid? Then you are done. Okay, you have what you call additional reaction. You have what you call elimination reaction. You have what you call substitutional reaction. So all this you have to know when and how to apply them. Let me just use an example here. Let me just look at just 1-2 questions here for the reaction. Maybe which question should I look at? Let me say, okay, this one can also be good. Let me check if I find another good question. Also, this one can be better, né? Yes. Yeah, this one can be better, né? Yes. Let's look at this question, né? Question number 10. Let me just make it a little bit bigger so that you see exactly. Let's cover all this question. Let's cover this question. Yes. Yeah, because I see this one has, yes, yes, the platinum, it has, yeah, it has everything I might need in this prediction. All right, guys, let's do this. They're saying that element A to E represent different organic molecules, X, Y, and Z. Organic compounds, man. Organic compounds, man, yes, sharp, cool, ne? Okay. Is compound P primary, secondary, or tertiary alcohol? We talked about this. Compound P. Where is compound P? It's the carbon atom with the functional group is here. How many carbon atoms attached? It's 2 carbon atoms. Therefore, it's secondary. You see? Secondary. If it is 2, means secondary. Primary. Your primary level is this. The first one. It means 1. The first level, 1 carbon atom attached to the carbon atom with a functional group. So this is automatically it is secondary alcohol. Then they're saying that give the reason your answer. We answered it. The carbon atom with the functional group is attached to other 2 carbon atoms. It must be complete statement. Don't fidget. Don't fidget. Yes. Question 2 is reaction elimination. Which one? Is A, elimination. Where is A? A is this going here. Is reaction represent elimination. Okay, from here to alkene. You see? You are from the alcohol, you are going to a double bond. Automatically, you have eliminated. You understand? Elimination reaction A is, write down the type of, they're asking you. Write down the type of elimination reaction. Because we are removing water, you are from alcohol to alkene, yes, you are removing water. So that type of elimination is dehydration. You are removing water. If we were adding, then it would have been hydration. But because you are removing water, so it becomes dehydration reaction. Ne? Yes. Then they're asking you, additional reaction represents reaction B by B. You see? Okay, so it means that from alkene to alcohol. Okay, they are saying, write down the type of additional reaction represented there. You see now, I'm adding the alcohol from alkene to alcohol. Therefore, it's going to become hydration. This one, because I'm removing this one, because I'm removing alcohol, I'm removing water, dehydration. Because here I'm adding, then it becomes hydration. Then they are saying that elimination reaction represented by D. Where is D? Elimination from this to this. So this is the alcohol. If I add hydrogen bromide here, it forms that. So what does it mean? It means that I've removed the bromide, hydrogen bromide here, and then I've formed this. So what reaction is that? Is dehydrohalogenation. Dehydrohalogenation, because I'm removing the hydrogen and the halogen. So it becomes, because I'm removing, then the word D. Hydro, meaning that I'm removing the hydrogen, then the halogen. That's why I'm saying the hydrohalogenation. You understand? So that is the reaction D. You see? It's simple. So it is simple. Then we go to sodium is used. Don't forget that sodium is a strong base. Ne? I told you, when do you use a strong base? When do you use an acid? You have to know all these conditions. Guys, don't go to the paper without knowing it. At least practice this question. This question you see there. Ne? You won't regret it. Ne? Yeah, you won't regret it. Used in a reactant in C. Where is C? Let me first clean up this because it looks ugly. Okay, sharp. C, where is reaction C? Okay, from hydro, because here it is hydrohalogenation. Ne? Here. Oh, here is substitution. I'm substituting this with this. Yes, substitution. So now they're saying, write the type of reaction that takes place in C. So, C, because I'm going back to the same thing, still is substitution. But which type of substitution is, because, did I say C? Which type of substitution? Yes. So now, because I'm forming alcohol, a component of water must be there. A component of water. So the reaction becomes hydrolysis. Hydrolysis. You are splitting it using water. The moment you add water there, then it becomes, yes. It's like a substitution, but water is there, therefore it becomes hydrolysis. What type of reaction takes place? So we are done with that. State two conditions. State two conditions which are supposed to be present in this reaction. Two conditions. Okay. The first condition is this base. They said it used in a strong base. So strong base must be there, and this base must be dilute. So strong dilute base. You understand? It could be sodium dilute sodium hydroxide. So you must add that word hydroxide. You understand? Yes. And then you don't stop there. You also had some bit of heat. Yes. So if you are changing, you are forming the alcohol, you're changing from alkane, then you have to use a strong base, and this base must be a little bit aqueous, dilute. Why? So that component of water is there, and then after that you add some small heat. You understand? Please make sure that you master this question so that you get all the marks. Write down the formula of organic reactant needed for reaction D. Reaction D. What is reaction D? They're saying write down the IPAC name of organic compound at D. So you have this, you form this. How will I know the number of carbon atom? Do you have to specify hydrolysis, like hydrolysis with water or base? When you say hydrolysis, definitely you are talking about using water. Ne? Yes. Do you know? When you say hydrolysis, it's enough you have said using water. Is it clear? But now, hydrolysis with water. Or you have to say strong base, dilute, strong base is cool. Or dilute sodium hydroxide. It can be dilute potassium hydroxide also. Why? Because these are strong base. Actually, the bases of group 1 element, except lithium hydroxide. Yes. Why lithium hydroxide? Because lithium hydroxide has a different bit of different chemistry compared to other elements which are in group 1. Actually, the first elements in each period, they have a little bit of different chemistry. Yes. So, but the other ones, they are good. Yes. All right. So, because this one is 1, 2, 3, 4, definitely if this one converts to this, yes, it's an alkene. Yes. So it automatically is gonna be 1, 2, 3. But now, you have to follow mechanical fluid. Mechanical fluid. I was forgetting that. Okay, sharp. Let me show you. Now, let's start from here. This one was here on common atom number 2. Definitely, the other ones is also gonna be 1, 2, 3, 4. 1, 2, 3, 4. The bromide is gonna be there. You understand? Yes. Now, because this you have 1, 2, 1, 2, so automatically the double bond is gonna be in between. It won't be in here. No, it's gonna be 1, 2, double bond. See, yes, it's gonna be there. Why not? Because this thing is here. Why not here? It doesn't become symmetrical. So you chase for symmetrical. So this one, it becomes a minor product, and then this one becomes a major product. This one also forms, but it's a minor product. What you are looking at in organic, we look for major product. So this one becomes the major product. So they want the IPAC name 1, 2, 3, 4. So it's bute. Remember, this one is alkane, alkene, alkyne. You stop on bute, and then 1, 2, 3, 4 is bute. 1, 2 is common atom number 2. 1, 2 is the same thing. So it's going to be bute 2. Yes, in. Bute 2 in. Don't forget that a word with a word is a comma. A word and a figure is a dash. Bute, you see, bute 2 in. If I had die, you see, die, it's fine. So if I have what? No. Me say see. 2 bromo. You see? 2. So what is this? Is a dash. What about if I have 2 die? So this one is a comma and a dash. So figure and a figure is a comma. Figure and a word is a what? A dash. Please make sure that you know that. Don't go without knowing that. If you have a question, let me know so that I sort it out. I think I'm done with the reaction. Unless you have any question, guys, make sure that you know dehydration. You talk about addition, which type of reactions which are under addition, elimination, and then substitution. You understand? And when and which condition. Use this question. If you don't have it, use it. Take a screenshot and then try to practice them. At least you try to cover most of them. And then don't also forget to know the esterification. This esterification, don't go without knowing esterification. Why is sulfuric acid being used? We said as a catalyst. Yeah, please make sure you know that. Let's go to the next question, which is yeah, here is not that a big deal. It's just a simple thing. There are some few things where students confuse or where they get messed up when it comes to the endothermic and exothermic reactions. So here we can get all the marks. Just a moment. Is Z positional isomer of compound Y. I've moved away from that. I don't know. What is it? What do you mean by Z? What is Z? Y? Let me check. Z. Z. The moment you add platinum, it means that you're adding hydrogen. The moment you add platinum, it means that you're adding hydrogen. Yes. So if you're adding hydrogen, then automatically it means that you have changed. Remember, it was a double bond, so you have changed. So it can't be a positional isomer. You understand? Yes, it can't be positional isomer. Why? Because the other one is alkene, this one is alkane. You see? So it can't be isomers. Yes. I don't know whether what you're saying is what I'm trying to answer. Okay, sharp. Let's go, guys, here. The graph, guys, once it comes the graph like this, you just have to take note of this. When you start from this, you go high, it means that you have taken a lot of heat inside. So definitely is going to become endothermic. And then when you go from here, and then you go down, then it's going to be exothermic. Why? It's like you feel cold. It means that it's exothermic. You have released this heat you are passing. It is what? It is exothermic. Yes. Even the heat you are taking out, you see that the heat is a little bit warmer. Yes. So it's exothermic. So guys, that one is done. Now, if this is A and then this is B, what is the... Let me just use this so that I don't waste time. Yeah, if this is a reactant and then this is product, so this is from top to bottom is exothermic, from bottom to top is endothermic. Yeah, they talked about it here. From here, yes, from here to here, how do we call that? This is the activation energy. You see, from here to here is the activation energy of the forward reaction. Because when you talk about the reverse reaction, from here to here is the activation energy for the reverse reaction. So it's the same thing here. Activation energy for forward reaction, activation energy for the reverse reaction. So I think you have... From the reactant to the product, the change in energy there is the enthalpy change. Please take note of that. The change there is the enthalpy change. And then we call it the enthalpy change. Then when it's the reverse, definitely it will be the same thing. Still the enthalpy change for the forward reaction, enthalpy change for the reverse reaction. So if they ask you to calculate, you must know whether they're asking you for the forward reaction or they're asking you for the reverse reaction. You have to know those two things. Now, this one is easy. But now, when it comes to this graph, these graphs, when a catalyst is added, how will this reaction behave? When the catalyst is added, what will the catalyst do? The catalyst, what it does, it gives an alternative way of the reaction. Suppose, for example, you are from here. What can I use? You are from your home to town. You can use a taxi or you can use a train, depending on if the train is there or not. Or you can use Taxify, whatever. But now, which one is faster? But you're going to reach the same destination. But the only thing which is going to be different is the time. So when you add a catalyst, yes, it just lowers the activation energy. But the product remains the what? The same. You see? It lowers the activation. It lowers the speed at which the reaction is taking place. It lowers the speed. It lowers the time you're going to reach in town. You understand? So that's how the catalyst works. Yes. So the function of the catalyst is to provide an alternative which has a lower energy for the reaction to take place. So it basically speeds up the rate of what? The rate of reaction. So done with that. When you go to rates of reaction, okay, this is where I want. This is where I want. Now as if I'm teaching. I didn't want to go everything in here. Okay, this is what I want. Guys, you need to know that when something is like that, is a product. And when something is like this, is a reactant. Reactant products are always increasing, and the reactants are always decreasing. And then, in most cases, the reactants, the products, they start from zero. If they don't start from zero, you will see them doing like that. So in most cases, they start from zero. The statement is saying in most cases. It does not mean that it starts from zero always. In most cases, it starts from zero. Then, that's number one. Number two, rate of reaction. When they ask you to define the rate of reaction, what does it mean? Is change in the concentration of the reactant over a specific period of time, per unit time. So you talk about time. Don't say rate of reaction is the rate at which reactants disappear per unit time. Then you are repeating, because the moment you say rate, it means time. So the rate at how fast the reactants are disappearing, or how fast the product are forming per unit time. So it can be concentration of product still per unit change in time. So change in the product over change in time, it gives you what called the rate. You must always know that. Yes. So there are some things which I need to talk about this. I will show you some of the questions which I want to talk about. Yes. Now check this question. There are factors which affect the rate of reaction. Please know them. Please know them, and how do they operate? Surface area. How is it fine or it is not fine? So I'm talking about big particles or small particles. That's a very important thing to talk about. So now, let me show you this question. Let me just pick a question here so that this one will work for me. This one will work. Yeah, let me just choose. This one can work. Let me see if I can find another one. Yeah, this one can work better. Yes, this one can work better. Let me see, it has this. Yes. Let's look at this. Let's look at this experiment. They're saying that zinc, the reaction of zinc in and excess there, guys. The moment they talk about zinc, it means that this one will never be a limiting reagent. There is someone who talked about the limiting reagent. Can you please talk about identification if a limiting is a limiting reagent? Yes, I'm here. Who was that? Raisima. I don't know whether I've pronounced your name properly. Yes. Guys, whenever you talk about, when you see the word excess, it will never be a limiting reagent. Actually, a limiting reagent is that reagent which finishes first before the other one completes. For example, you have a car, the car is fine, you are going to a specific area, and the fuel is finished. So the fuel becomes a limiting reagent. You understand? The fuel becomes what? A limiting reagent. And then, if the fuel is there and the car can't move because it's broken down, then automatically the car becomes a limiting reagent. So a limiting reagent is that factor which finishes first before the other factors have finished? You understand? Yes. Or is that reagent which finishes first before other factors or before other reagents have what? Have finished, and then it causes the reaction to become complete, or there is they stop. So now, here is a question. They are saying that hydrochloric is used in investigating the factor that's balance equation, zinc, hydrochloric acid, and then zinc chloride sharp. The reaction addition used in obtained for experiment is summarized in the table below. Same mass of zinc is used sharp. Same mass of zinc is used. Then it's completely cover, and then they're saying the reaction time takes place sharp. Now they're saying that question number 1. Experiment 1 and experiment 5 are compared. Write down independent variable, and dependent variable. In this case, what are you going to look at? What is the independent variable? They're saying experiment 1 and experiment 5. So what is different here? This is the same. This is the same. This is the same. This or this is different. And then time is also different. So what happened when I increased the temperature, the time reduced, meaning that the independent variable here is going to be temperature. So temperature will determine the speed at which this reaction is taking place. Yes. Define the rate of reaction. We talked about it. Then write down the value of x. What is the value of x here now? The value of x. Let's see here. Is 15. This one is the same. This one and this. This one is different. But they said this is in excess. So it means that you're increasing the volume doesn't affect anything because they said it's in excess. So whether you put 600, as long as it is above 200, doesn't affect because they say that this is in excess. So it means that this and this is the same thing. Then this state granule, this is also granule. It's 25, it's 25. So automatically, if this is 14, because everything here is exactly the same as this, what is different is this, and this doesn't affect. Yes, so automatically this is gonna be 14 too. Yes, you see. Yeah, so guys, I did a simple research about, I keep on repeating this topic. It looks to be easy, but it's the most failed topic for over 10 years. Yes. Why? Because it requires you to analyze. You have to analyze. It's not too much calculations, but still people tend to fail it. Yes. Anything related to thinking, critical thinking, sometimes people go off. Then they're saying that question 3 point sharp. Write down. Okay, we are done with that. Maxwell. Yes. This distribution curve, particles of experiment 1 and 1, 3 and 5 shown alongside. Yes. Okay, they're saying that. What is the question they're saying? Okay. Experiment 3, give a reason. Which one is experiment 3 and give a reason for your answer? Experiment 3. What's happening with experiment? Because they say that experiment 1, you see guys, you have to know how to analyze this. Ne? You have to know how to analyze this. Experiment 3. This is experiment. Let me now clean out this because I don't want it to disturb us when you're analyzing. Yes. Experiment 3, experiment 1, and experiment 5. So what is the difference here? Experiment 1, okay, this and this, they are the same. This is different, the concentration. So it means that if the concentration, we expect this to be a little bit higher, a little bit faster, ne? But we shall find out if it is going to be faster, ne? Volume doesn't matter. Why? It's the same, and number 2 is dilute. So we said it's excess. We said it here. So it doesn't affect. State, this is powder, and this is powder. So it's the same. You see now the key point, the first key point is here. And then we have, just a moment. Yeah, sorry guys, just all right. So we have analyzed that, né? So now if we analyze this temperature, it's the same temperature, is high temperature. This can also be another factor which might lead to the reaction to be a little bit faster. Time, this time, and this time. So now it shows that this one is a little bit faster. Okay, now remember, the more, if this is the original graph, the more you come to this side, the more it's faster. The more you come this side, the more it's slower. So we know that. So now let's go and then start analyzing. What is experiment 3? Experiment 3, if you look at it, is just normal. If you look at it here, it shows that it's just normal. So if you look at these questions, you'll see that experiment 3, you have this, you have this, and you have this. So automatically it shows that, this shows that experiment 3 is C, is graph C. Why? Because it's just normal. It's not that faster as this, so it's not as fast as this and not as slow as this. So automatically C becomes experiment 3. And then give a reason for your answer. What can you say about experiment 3? No. Because this one, temperature. No. If you look at the temperature, sharp, number of particles having the sufficient energy. Yes, but it has a high concentration. So this shows that it has a high concentration. You understand? It has a high concentration. Check. Yes. So this one becomes experimental because of the high concentration here. Is it clear? It has a lot of particles in the reaction, but the number of particles which are reacting to form products are not that many. The reaction is not that faster. You see? So we have got it. So we go to question. They're saying that give a reason for your answer. Maybe you can say that it has the highest concentration of particles, or has more particles, yeah, that are in the reacting vessel. You see, it has the highest. If you look at it here, it has the highest. Then number 2, we can say that experiment 3, now you're saying that give experiment 5. What is experiment 5? Experiment 5, what is different? It has the fastest rate. You see? Meaning that it has high number of particles which are colliding, in other words. So if you look at this, then automatically this is going to be having the highest number of particles. You see? These are the particles with sufficient energy. Don't forget, they can ask you what is this shaded area. These are particles with sufficient energy to react. So automatically C is going to be reaction 5. Why? Because it completes the reaction very fast, and also has the high temperature. It means that the particles have sufficient energy to react. Do you understand? Yes. So that becomes number 3. So it's cool. Now you go to the next question. What are they saying? What is the function? Experiment 6 is now conducted using the catalyst. Catalyst, remember, it speeds up the rate of reaction. Eh? Yes, it speeds up the rate of what? Reaction. So they are saying that the same condition as for experiment 1. What is the function of a catalyst? Speeds up the rate of reaction, or it provides an alternative way in which the reaction can take place in a faster way. Yes, so basically speeds up the rate of what? Reaction. Then how will the heat of reaction in experiment 6 compare to experiment 1? Will it be equal to? They're saying that heat of reaction. Remember, a catalyst doesn't change anything, so it just makes the speed. The heat remains the same, so it will be equal to. Yes. Calculate the average rate of reaction with respect to zinc in experiment 2. If 5 grams, 1.5 grams of zinc is used. So in this case, what are you going to do? So the rate of reaction, you can talk about mass, yes, and then find out the number of moles, and then after that you can change those moles. So in this case, we don't know do we know the mass? Yes. What did they say here? They said in experiment 2 is 1,5. Yes, so in this case 1,5, and then but they said 0,5. So meaning that we need to find out the number of moles which reacted. If 5, so number of moles is equal to mass over molar mass. So it's gonna be giving me 1,5. Zinc is what? Zinc is 64.5. Yes, 65. You can check from the periodic table and then find the perfect answer. Ne? So here is gonna be find the answer, maybe 0.02, 0.02. It could be 0.02 there. If you divide with this, it's 5 cancel 1, 0.0. Use the calculator and then find out. Ne? And then after that, so now I have the number of moles. These are number of moles. So don't forget that change in the number of moles, rate of reaction is gonna be change in the number of moles over change in time. So change in the number of moles or change in the concentration. So it's gonna be the final is 0. So it means it's gonna be final minus initial, which is 0 minus this number of moles, 0.02 maybe, divided by you started from how many minutes did we use as experiment what? They said as experiment 1. As experiment, let me read again. They're saying that, experiment 2, the number is 14. So it means that is gonna be 14 minus 0. So when you subtract here, so the answer is gonna be 0.02 divided by 14. It could be 0.02, or you will calculate maybe 0.024 or something. So the answer you get here, it must be corresponding to this. Ne? Yeah. It could be 0.02 or 0.0. Yeah, you can calculate it. So that's how you can calculate the rate of reaction. So guys, basically in this topic, make sure that you know when they bring the powder, the reaction is very fast. When they bring granule, the one which has the powder has a faster rate compared to the granule. When they bring a high temperature, the one who has a high temperature is faster than the one which has a lower temperature. When they bring the word excess, guys, make sure that, now I'm talking about the prediction, make sure that that excess, it does not finish up fast. In most cases, whenever they bring it, you have to ignore it. Why? Because it is in excess. Do you understand? Yes, it will not finish up unless the volume or the volume they have used there has, you have reduced it. Then that's when it might be influenced. Then when they say what is this shaded area? Now let's go to this. What is this shaded area? What does it mean? These are number of particles with sufficient energy. You understand? Then when is temperature applied, what is going to happen? The number of, what happens, the particles redistribute themselves, né? And then you have more on the side which are shaded. When is concentration increased, the number of particles which are reacting, the number of particles in the reacting vessel, they increase. Do you understand? Yes, they do increase. Then now when you go to when they ask you how do you explain the reaction using the collision theory and the collision theory, or the increase in temperature or catalyst, please make sure that you know. When you explain this, there are some things we are looking at. For example, you have lower temperature and then high technology? How is the high temperature going to affect? How is the high temperature going to affect? The high temperature, when you increase the temperature, the number of particles with the sufficient energy will increase, meaning that increase in temperature increases the number of particles having a higher kinetic energy. You understand? So if they have higher kinetic energy, it means that you have more particles with the sufficient energy. Yes, which will increase the rate at the rate of collision per unit time. The word per unit time, we need to see it. And then if the rate of collision is increased, then this collision must be effective collision per unit time. And if it is increased, then the rate of reaction is going to increase. Guys, you need to know that. When it is about concentration, it increases the number of reacting particles. So it means that it will increase the number of particles which have sufficient energy, hence increase in the number of effective collision per unit time. Hence the rate of reaction also increases. You have to know that. Don't make a mistake to go to the paper without knowing that. Yes, I think I'm done there. Can you please do grade 12 geography paper 1 prediction? Okay, I'm gonna speak to the teacher. I'll speak to the teacher, and then yes, you'll see. Keep checking on our YouTube channel, or subscribe so that you are able to get the notification. You subscribe and then you click on the notification so that if we put it in, and then you are able to yes, this is the question someone was asking, you see. So let's go to the chemical equilibrium, acids and bases, and then we finish with the, let's just be very fast, ne? Yeah, because now I have only 10 minutes to finish this, because I'm supposed to go to help this grade 10 and grade 11s, ne, for chemistry. All right, next year will be full-time. Will help you, those who have not become members, make sure that you become members. Grade 10, so you will be in grade 11, grade 11 will be in grade 12. We will be here. Make sure that you subscribe so that you don't miss out anything. Yes. All right, let's go to factors that affect chemical equilibrium. What is chemical equilibrium? You must know that. Oh, you must know that. You must know how to state Lactarian's principle, this, and how to apply it. Don't make a mistake to go when you don't know it. So what disturbs people in a chemical equilibrium? There are two things. basically the calculation, because that's the big deal there. And then number 2, how to use Leclerc's principle to apply. That's all. What are some of the factors which affect the chemical equilibrium? We have concentration, we have temperature, we have pressure. Those are the 3 factors which affect the rate of chemical reaction. Yes, so those are the 3 factors which you have. If they ask you the factor which affect the chemical, the Kc value. Kc value. Now this is Kc value. Here is only temperature. The factors which affect the chemical equilibrium is temperature, pressure, and concentration. Yes, catalyst, it affects the forward and the reverse, so that one is not a big deal too much. But the big deal for chemical equilibrium are these 3 factors. But the Kc value is only affected by temperature. Please take note of that. They can bring it and then ask you, temperature has increased. Tell us whether the Kc value remains the same, increased or decreased. So it will depend on whether it's endothermic or is exothermic. I'll show you. So we are done with that. So we say that this is forward reaction. This is forward reaction. Why? Because the reactants are decreasing. And then this is the reverse reaction. Why? Because this is the forward reaction, and then this is the reverse reaction. If the forward reaction and the reverse reaction are equal, then it will be equilibrium. So what is equilibrium? Is when the rate of forward reaction and the rate of the reverse reaction are equal. Someone is asking me about agriculture. Unfortunately, Cindy, I will not be able to do agriculture this year, but next year, yes. Unfortunately, I'm sorry for you people who are doing agriculture this year. Yes, but I will see if I can do it, but because I'm the teacher for the agriculture science, so I don't know whether I'll have enough time for preparation for agriculture. Yes, but I'll see. But definitely next year, God willing, I'll do so. Yes. But if you have questions, you can ask me. Maybe I can send you resources and stuff like that. Yes. Okay. Then for the reaction, reverse reaction, we are done with that. What concentration affects? Here, there are some things which you need to know when it comes to chemical equilibrium. Listen carefully, guys. When does temperature affect? When does concentration affect? How does the graph look like when it's temperature? How does the graph look like when it is the concentration? And how does the graph look like when it is? Yes, so now let's talk about it. So check how temperature affects. You see? Just check how the shape of the graph looks like. It is not sharp. It's not straight. It's not straight. Sorry. This computer is disturbing me. It is not straight. It is bending. Yes. Check how it looks like. It's bending. While if you look at for case of the concentration, check how it looks like. It has a sharp spike. It means that either you have added or you have decreased. Can I repeat that? For the case of temperature, how do I know that this graph is for temperature change or it is for concentration? Temperature, the graph is increasing gradually. It has that gradual bend, while concentration, it is sharp. When you add the concentration, it is automatically sharp. Yes. Now, and if you have 2 of them, how do you know that this is a product or it is a reactant? So if this is the reactant, check, this is the reactant, they are being used up. Now here they go up very fast. It means that you have added the reactant, you have added that reactant. That's what it means. And then now once you add the reactant, then it continues to go down. This reaction did not reverse. No. If it was reversed, then the reactant would have been product and the product would have been a reactant. How do I know that it has reversed? When this one goes like this, and then my drawing is not good. If this one is going like this and then this one goes like this, now you see this one is going up. So when it reverses, this goes like this while this one goes like that. You see, it forms that X. Yes, they cross each other. But now here, they did not do that. This one just increased, then continue with the same shape as it started with. This one also started increase because more reactant had to increase, and then using the reactance principle, then the stress is supposed to be what? Removed from the what? From the system, so that the system attains the equilibrium the way it was. Is it clear? Yes. So concentration, I've showed you, and then temperature, I've showed you how it looks like. Catalyst, it does the same way. Two of them, they change at the same time. If you have two things, the two graphs will change at the same time. What about pressure? What about pressure? Remember, pressure only works in gases. It does not work in liquids and does not work in solids. So you need to go when you know that. Yes, it doesn't work. It works only in gases. Yes. So how do I know that is pressure being added? Yes. In most cases, when the pressure is added, you might see a slight change. It reduced or added. You will see that there is a slight change based on the number of moles each compound is producing, but the change looks the same. For example, if this is 2 moles and then this is 1 mole, when I increase the temperature here, the 2 moles, what is going to happen? When I increase the temperature, yes, what's going to happen? It means that the volume is going to what? Is going to decrease. You understand? Then it means that the reaction, the particles are going to come closer, and then the reaction is going to speed up. You understand? Check. It goes very fast. And even the product or the reactant, the reverse reaction is the same thing, so it's going to also reverse. And then that's why you have this and this at the same time. That's why you have this and this at the same time. But the change will depend on the number of moles, because this is 2, so this one must show 2 times the effect of this. Yes? Let me show you. You see now, this one is half of this. Even this one is half of this. That's why I'm saying that this one, the one which has higher number of moles, must show 2 times to the other one. Yes. So now if it's like this, now you can apply. Ne? You can apply. You see that it's the same thing which happened here. You see? Even here, you see that this is almost 2 times. Eh? The dotted is 2 times to this. So that is pressure. So pressure, you see both of them, they're increasing, but the other one is increasing more. Then concentration. Concentration, one is spiking, then another one is gradual. And then temperature, both of them are gradual. Ne? Both of them are gradual. You see? Yes. So please, you need to know that before you go to the paper, because if you go to the paper without knowing them, it might affect you. So that is the first thing you need to understand. The second thing is reactions. Just a moment, I'm checking. Yeah. Okay. All right. Let's go to the calculations. Guys, you have three calculations you might find in the paper. Ne? There are 3 of them, but one is gonna come. It can either be direct. Ne? It can either, the question might be direct. The question might be hidden somewhere. I'm going to show you the first phase of hiding, or it can be hidden the second phase. Let me show you the chemical equilibrium. Let me check here a question. Don't you think this one is good? This one could be good. Question 6. Question 6, they are saying that, what does the double arrow indicate? Okay, double arrow indicates that it's a reversible reaction. Then they are saying that is the above reaction endothermic or exothermic? You have to look at the enthalpy change here. If it is greater than 0, then it means that it is endothermic. If it is less than 0, you see, if it is less than 0, it means that it is exothermic. So in this case, it's greater than 0, therefore it is endothermic. Then they are saying that initial unknown amount, yes. Now you have unknown amount. You don't know the amount you started with. So they can give you when you start with unknown amount. They can give you when one element has been hidden, yes. And then they can give you, and then they give you the case C. And then they can give you don't have case C. And then you have to manipulate everything. That's where the problem comes from, when they ask you to manipulate everything. So now here they're saying that unknown amount of reaction is this. Okay, I'm gonna give you few minutes for you to do this question. Do this question for me. I'm gonna give you 5 minutes to do this question for me, and then after that I go through it very well. Yes, so that when I do it, you see the mistake I was talking about. Yeah, but don't forget that this is slightly a hidden question. Yes. All right, I think you have got it. I've got it. Thank you for that time. All right, let's see. Let's go through it. They're saying initially unknown amount of carbon dioxide is exposed to hot carbon. They're saying hot carbon. Anyway, sharp at this temperature. That's not a big deal. This is a very important thing. Volume. You need to know this volume. If it is not decimeter cubed, you have to put it in decimeter cubed. And then they are saying that at constant for the reaction at temperature is equal to 14. Temperature is equal to 14. It's not a big deal. The equilibrium, it was found to be this. Found at equilibrium, it was found 180 grams of carbon monoxide of this. At equilibrium, you understand? Sharp. Then they are saying that okay, how will the equilibrium concentration of product compare to that of the reactant? Choose. What are you supposed to choose? Choose larger than, smaller than, or equal to. So what are you supposed to talk about here? How? They're saying how (6.3) how will the equilibrium concentration of product compared to that of reactant? How will the equilibrium concentration of product compare to that of reactant? So now if you are looking at the concentration of the product, Let's see the Kc value. Where is the Kc value? Did they give us the Kc value? They're saying that the container, the volume concentration constant Kc for this reaction at this temperature is 14. Okay, now I see now. Oh, this is 14. So the Kc, if the Kc is bigger than 0, then it means that the product is more than the reactant. If the Kc is less than 0, then the product is what? Is lower than the reactant. Let me give you an example. If the product is 4 and the reactant is 2, so the answer is gonna be 2. You understand? And then now if the product is 2 and the reactant is 4, what is the answer here? The answer is gonna be 0.5. You see? So if the product is bigger, then the Kc is gonna be a little bit bigger. So in this case, you'll find out that the product is a little bit what? Big. That's why the Kc value is much more higher. Is it clear? It was found, yes, sharp. Then number 2, so the answer is gonna be larger than. Calculate the initial amount of carbon dioxide present. So in this case, what are you going to do? Let's do this. You have to use the rice method, and then we are able to get everything here. I don't know what you are using, but rice. I call it rice. So let's go to the elements. Elements, what do we have? This is a gas, this is a solid, so I don't include this out because this is a solid. We don't include the solids and liquids in the chemical equilibrium. So I'm going to have carbon dioxide, and then I'm going to have carbon monoxide. I'm going to have carbon monoxide. Then we go to the mole ratio. Carbon monoxide is 1. Carbon dioxide is 1. And then carbon monoxide is 2. Carbon monoxide is 2. You see? So now we are covered with that. Then we go to the initial moles. The initial moles, remember, since it's a product, this one, carbon monoxide, since it's a product, so initial is going to be 0. What about this? Did they tell us the initial? Unknown. They said unknown amount of carbon dioxide. So since it's unknown, let me call it X. I like to use X, or you can use Y, whatever. Then now, you see now, they did hide the initial mole. That's the first instance. So if it is hidden, then now look at this. So what are we supposed to do here? Now they are saying that concentration, yes, change. What they used, which we call the change. Change here. They change here. What they say here. So now I need to find out the number of moles, because here they say that they use at equilibrium. It was found out that it is 1,6168 grams of carbon monoxide. Therefore, I have to calculate this. Carbon monoxide number of moles is equal to mass over molar mass, of which number of moles is going to be 168 over molar mass of carbon monoxide is 12 plus 16. You understand? So which gives me 28. So number of moles is going to be 1, over 28, and then when you calculate it, it's going to be 6 moles when you divide. So it's going to be 6 moles. So it means that the change here is 6. What we produced is 6, and what remained at equilibrium is exactly 6. Yes, because that is product. Is it clear? Yes. Now, if we come here now, if this is 6, what did I use? Then definitely what I used is gonna be, because this is 2, this is 1, therefore this one is gonna be 3. So what I remained with, what I started with is minus what I used, then I get what I remain with. Therefore, I'm gonna say X, what I started with, minus what I used. Yes. So I'm gonna get what I remained with. You understand? So now this is the concentration. Concentration. So the concentration at equilibrium is gonna be X minus 3 divided by the volume. The volume, this volume I talked about, this meter cubed, which is 2, and then 6 divided by 2. You see, 6 divided by 2, so it's gonna be here 3. So now after that I can apply to Kc. Kc value is gonna be equal to it's gonna be equal to what? I come here and I find out where is this, I find out where is it. Yeah, the Kc they said is 14. So the Kc is 14. Let me first use the expression and then I substitute. So it's going to be Kc is equal to the product, which is carbon monoxide to the exponent of the number of moles, which is 2, divided by carbon dioxide to the exponent of the number of moles, which is 1. Therefore, Kc is 14, which is equal to 3 squared divided by x minus 3 over 2. Yes, so when you reciprocate, then you are able to get, then you solve for the x, then x, it must give you this number they have given you here. When you calculate, it must give you that number. Yes, so basically it's gonna be that number, which is 4.29. That's the first instance. So the first instance, they bring this Kc when they have hidden something here. You understand? That's the first instance. Then the second instance, guys, they bring it when it is open. They can bring it when it is open, or they can bring it when they have given you. Let me check and see. Reverse reaction, please don't go without knowing that. What is a chemical equilibrium? Please know how to define it. In a closed system, it must be in a closed system. So please don't go without knowing this graph. I explained to you. So now the second question can be, yes, in terms of the graph. They bring the graph and then they ask you to identify from the graph. You understand? Yes. They give you this and then ask you to identify from the what? From the graph. So what do we do? Now, if the question comes like this, what is dynamic chemical equilibrium? Okay, dynamic equilibrium. Use the information, the graph, write down x, y, and z. Sorry, x, y, and z, x, y, and z. So you have to read here. The equation below represent the hypothetical reaction of equilibrium. Okay. After 2 minutes at a room temperature, the x, y, and z represent the number of moles balanced equation, this, and this. The graph shows the change in the number of moles or reactant versus during the reaction. So now they're saying that dynamic equilibrium. Okay. Use the information. Define this. Okay. What is x? 2 minutes, x, y, and z, sharp. What is x? So this is a product, and these two are reactants. Did they give you equation? Okay. This is product. This is definitely, this is z, and then these two are reactant. But this is C, yeah, okay, they showed you. Okay, the number of moles. Okay, at equilibrium, this one is 4. This one is 8. You understand? So it means that x is on A. So if this is 8, this is 4, definitely this is 2, this is 1, because if this is 4, this is 8, it means that this one goes into 2 times, né? Yes, so this is 2 sharp, so it means that this is 4 moles, this is 8 moles, while this one check is 3 times, meaning that this is 3. You understand? So x is 2, y is 1. Is it B? Yes, because this one is 4. Because this one is, someone might say, I don't understand. Okay, here it is 4. It's for B. And then here A is 8. Is for A. Ne? And then C is 12. Divided by 4, divided by 4, divided by 4. So you see it's 1, it's 2, it's 3, isn't it? That's why I'm getting these numbers from. So basically, C is gonna be 3. I think I'm clear there. Then you see how you can identify the number of moles and stuff using the graph. So we can bring it in form of what? In form of a graph. And then after that, they ask you the constant hypothetical volume closed system. So now you have the volume. This is the one which we use to divide at 4 minutes. At 4 minutes here, the temperature of the system increased to 60. When you increase the temperature, what does it mean? Does it favor the reverse reaction or the forward reaction? You have to first identify whether this reaction was exothermic or endothermic. So in this case, when they're saying that is the reverse reaction or at T. Okay, check here. It was like this. Then it reversed. You see? So since it has reversed, what does it mean? So it means that it is an endothermic reaction, because the temperature the system was increased to 8, and is the reverse reaction endothermic or exothermic? You understand? So at first it was going like this, né? Normally. When you increase the temperature to 60, it reversed. Definitely it favors the, if it was endothermic, if it increases, if it reverses, then automatically the reverse reaction is endothermic. It's the one which requires heat because you have increased the heat. If it doesn't reverse, it just increases, then the forward reaction is automatically endothermic, the forward reaction. But if it reverses, then the reverse reaction is the one which is what? Endothermic. Yes, because increase in temperature favors the endothermic reaction. Then from there, they're saying that calculate the case C at room temperature when the volume is this. Now this one is simple. Why? Use still rice method. Rice method. Rice method. Rice. Whereby elements here, you look at X, Y, and Z. X, no, it's A, B, and C. So this is basically the product. In the mole ratio, we say that A is 1, B, A is 2, B is 1, and then C is 3. And then you go to initial. What did they started with? This one started from 0, this one started from 8, started from 16. You see, this one started from 0, and this one started from 8, and then this one started from 16. Isn't it? A, where is A? A started from 8. Ne? A started from, no, B started from 8, and then A started from 16. Yes, basically it's correct. Then you go to change. How will I find the change? The change C C it is 12. Definitely, if C is 12 and at equilibrium, that's what is produced. Even at equilibrium is 12. So 12 goes into this, what was used here. 12, if this is 12 divided by 3, so it's going to be what here? It's going to be 4. And then 12, 2 out of 3 by 12 is going to be 8. Isn't it? Because it's 2 here, here is 3. You understand? So if I have, if 3 is equal to, it gives me 12, then 2 will give me what? It will give me x. When I cross multiply, I can find the x. You understand? 3x is equal to 12 times 2. So when you divide, you'll find out it is what? Is 8. Now, this one is going to be 8 minus 4, and then this one is going to be 16 minus 8. Isn't it? So which gives me 8 here, and then it gives me 4 here. Then after that, I have 8 divided by the volume. The volume which is 3 even here. 4 divided by 3 here is 12 divided by 3. So after that, I find, once I get there, the answer, and then I substitute it in Kc value, the Kc expression, whereby I will say that Kc is equal to and then I get the answer. You see, it's simple. You guys are gonna pass the paper. Then the last phase of Kc is they give you the reactant, they give you the product, and then they just hide what was at equilibrium. That's all. So you still use the same principle. You will be able to get the what? The correct answer. Let's go to acids and bases, and then we conclude with the acids and bases. Acids and bases. So if we go to the acids and bases, okay, so let's go to the acids and bases. All right, so here when you go to acids and bases, there's some things which you need to know about acids and bases. What is an acid based on Arrhenius, and what is an acid and the base based on the Rory? So, or Bristol. Okay, basically acids, then you need to know this one is cool. You have to go knowing that Arrhenius is the proton donor, and then the substance which produce OH. That is Arrhenius, and then this is an acid is, did I say? Arrhenius, an acid is a substance which produces hydrogen ions in aqueous solution, and then a base is a substance which produces OH. Well, Loribros, it's an acid is a proton donor, and then a base is a proton acceptor. So basically, you know, I have to know that. Conjugate acid base, this one is simple. If you identify one side, if you identify the acid, then the other one is going to be a base. You understand? And what received then is going to be the acid the other side, because it's supposed to release that. So for example, hydrogen ion from here is going to be taken to this. So therefore this one becomes the acid, and then this one becomes the base. So when it comes this side, this one has obtained the hydrogen ion. So it is the one which is going to become the acid to give this to this, so that it goes back. So this and this becomes this, and this becomes the conjugate acid base pair, and then this and this becomes the acid conjugate pair. So you have to identify one side, which one is acid, which one is the base. Yes. Amphoteric means substance which can act as both acid and a base. Base example is water. But sometimes they can bring a question like sulfuric acid, and then ask you like this, plus H2O, then you form hydrozonium ion plus hydrogen sulfate, like that. You see? So now this can act as acid and can act as a base at the same time. You understand? So you have to know which one, because now if I bring it here like that, and then I add water here, and then this is now I form hydrozonium ion again plus sulfate. You see, here it can act, here it is a base, because it's going to receive from this and then it goes back to this. Here it is a base, né? But when it comes here, it becomes the acid, because it gives this to this and then forms the hydrozonium ion and the sulfate ion. So in this case, it can act as acid, it can act as a what? It can act as a base. You can also bring phosphoric acid. So please know those things, né? Yes. Then what is acid? We have three types of acid. We have acid which is a diprotic acid, and then a monoprotic acid, and then a triprotic acid. When you say a diprotic acid, monoprotic means that acid which can produce one hydrogen ion, like nitric acid. And then diprotic acid is an acid which can produce two hydrogen ions when dissolved in water. And then a triprotic acid is the one which can produce three of them. So basically this is a tri, because it can ionize. And then these acids, when they ionize, they can act as a base and acid at the same time. Is it clear? Yes. So please don't go to the paper without knowing that also. Then another thing is how to calculate the pH. pH is equal to the negative log of hydrogen concentration, and then you are able to get it. Sometimes the hydrogen concentration is not given, hydrozonium ion is not given, therefore you have to use pH plus POH is equal to 14, or the concentration of the acid. Yes, you find the concentration of the base, and then after that you find the mole ratio, how many hydrogen ions which are there, and then after that you are able to calculate the pH. You understand? Yes. For example, you have sodium hydroxide plus hydrochloric acid, and then they give you sodium chloride plus H2O. Ne? Then now they want you to calculate the pH of this, but they have given you the concentration of the base. Definitely, if you have the concentration of the base maybe 0.3, yes, then you have to use the mole ratio, whereby you say its mole ratio is 1 to 1. Definitely, if this is 0.3 0.3, then automatically even this one is going to be 0.3. And then now use this to calculate the what? The pH, because now you have the hydrogen ions. You understand? Yes. The number 2, this could be a sulfuric acid. Ne? Yes, the mole ratio, you'll find out it's 1 here, and then here it's 2. For example, I'm just giving an example. Then automatically, is 2 is 1. Then you have to look at the number of hydrogens which are there, which are being released. If this sulfuric acid is 0.3, then automatically when it ionizes, it's going to give me 2 of them. So I have to multiply it by 2 so that I know the actual number of ions which are there for sulfuric acid or for hydrogen ions, because each sulfuric acid is a diprotic acid. Is a diprotic acid which produces 2 of them. So if the concentration of sulfuric acid is 0.3, then automatically I have to multiply it by 2, and then I can use it to find out the pH. Yes. If it is 3, then I have to multiply it by 3. If it's 1, then it's automatically I just apply it the way it is. Then hydrolysis, when you talk about pH, which is what is a strong acid, and then what is a weak acid, which is a strong acid. A strong acid is acid which can ionizes completely when dissolved in water. Ne? Yes, while a weak acid, it ionizes partially when dissolved in water. And then a strong base is the one which they dissociate completely when dissolved in water, and then a strong acid is the one which dissociate. A strong base, a weak base is the one which dissociate partially when dissolved in water. Please don't go without knowing those things. Yes. The pH indicator is also good to know, but also you need to also know the shape of the graph. If this is 7, then automatically if this starts from there and then ends there, it means that this is a strong acid, strong base. When it goes like this, it means it's a weak base, is a weak acid, strong base. You see, if this is the pH. And then when it comes like this, strong acid, weak base. Like if this is 7, you see that the upper part is shorter. Here is equal. Here the lower part is short, while the lower part is short, the upper one is. You understand? So this one, it means that it's a strong acid, weak base. Then this one, it shows that is a strong base, strong acid. This one means that it's a weak base, weak acid, strong base. You understand? Yes, a weak acid, strong base, strong acid, weak base, strong base, strong base. And then what about when it's like this? Yeah, it means that it's a weak acid, weak base. So you need to know those graphs so that at least you know how to interpret. Then calculation is also simple. You just have to go for you use this. You know how to use this. Whenever they give you, find out the number of moles of this, find the number of moles of this, and then this automatically when you fill in, it will be only one part which is supposed to be replaced. So make sure that you know how to manipulate that. Number of moles is equal to mass over molar mass, or over mass over molar mass, or concentration. If you're comparing number of moles with the concentration and the volume, you have to know that. Please check your formula sheet. It's good that they give you formula sheets. So you guys, acids and bases, you pass it. I know that the questions is not that difficult. Then lastly, we go to still the same thing here. Find the number of moles of the acid and find the number of moles of base, and then you apply that formula. Please go when you know how to apply in that formula. I'm trying to rush because of the time. Yes, let me just finalize up with this and then just show you what you cannot go without knowing. So here, you need to know what is a galvanic cell, what is an electrolytic cell. When you just look at the diagram, what you need to know. If you find out that it has no external battery, then automatically it is a galvanic cell. It has a salt bridge. What is the function of the salt bridge? We say that salt bridge, it provides spectators so that they can try to remove the effect of impairance or from stopping the cell. It helps to stop the cell from working. It prevents that. It provides ions which is going to prevent this cell from working. For example, if this is positive charge, and then this is a negative charge, you understand? It's supposed to be negative, yes? But now electrons, remember negative charge is supposed to have a negative electrons. But now the electrons move to the positive side. You understand? Now it leaves this to be a little bit positive. You understand why? Because the electrons are moving to this side. So it leaves it a little bit positive. You understand? Now this one is supposed to be positive, but now because it is positive, it attracts the electrons. So electrons come this side. So now it becomes more negative, yet it's supposed to be positive. You see? So what do we do with the salt bridge? Because this is supposed to be negative, so it brings the nitrate ions, so that it keeps this to be more negative, so that now even if the electrons go, it remains negative. And then this one, since it's supposed to be positive, and then these electrons are coming, these electrons, they try to neutralize this positivity, so the potassium ions are going to be produced here, so that the anode will continue with the oxidation and the cathode will continue the what? The reduction. So the positive ion from the salt bridge is going to come here. Those are what called the spectators. It prevents the oxidation and reduction from stopping, or it prevents the cell from being impaired. Yes, so, and also connects the two cells. Those are function of the salt bridge. It completes the circuits, all those things you can talk about. So basically, it's simple to pass when it comes to this. Yes, but because now, this is dissolving it from the ions, while this one, so it means that this one is gonna have to reduce in size, while this one is gonna have to increase in size. Yes, you understand? Yes. And then number two, because this substance, it's dissolving, while this one is being used up, this one is going to become pale. It's going to become pale. Why? Because the ions which are being used up here are not being replaced. The copper ions, they are not what? Being replaced. So you need to know that when it comes to the galvanic cell. Then number two, when you get a positive value, then it means that the cell is spontaneous. It can continue on its own. When you get a negative value, it means that it is non-spontaneous. It cannot continue on its own. It will require an external battery for it to what? To continue. So basically, that is it. Then you need to know what you call the cell notation and the cell reaction. Okay. Half cell, you have to know all those things. If it is a gas, what am I supposed to do when it comes to that? So okay, now cell reaction, basically what happens, because here I have oxidation is happening here, isn't it? So basically I'm gonna have zinc. The zinc is gonna dissolve here. Zinc plus zinc gives me zinc 2 ions plus 2 electrons. And then here I'm going to have copper 2 ions plus 2 electrons. Then I get copper solid. So if that's the case, then now I can come. These are half equations. Yes. So basically what happens here, so now it's going to be here copper. I combine these two. Actually it's here copper 2 ions plus zinc. This gives me zinc this plus copper. You understand? So basically that's what you do. Then the cell notation, you tell us what from the anode, and then you go to the cathode. So it means that it's going to be zinc gives me zinc 2 ions, salt bridge then you write this is going to be copper 2 ions, you see, copper 2 ions, and then slash copper. So that is the cell what? The cell notation, you see. But what if this was a gas? What if this was a gas? What if it was a gas? It is not a solid. Okay, it's not. So it means that if it was a gas, for example, if this was a gas copper, then I have to put this in brackets like that, or I just have to slash it, and then I put, for example, if it is platinum, so I slash, say that platinum, which shows that this one is reacting. For example, if this was hydrogen ions, and then hydrogen gas, and then platinum, you see. Yeah, that's how you can do the cell notation. Then to calculate cell potential is cell minus is equal to cathode minus the anode. Then you guys have to look at into the reactivity series. Check. I used to tell you that this must start with the one which has lithium on top, and then it ends the one which has lithium on top. So now the one which is on top is more reactive than the one which is on bottom. So now that's how you can identify. For example, I have this zinc and lead and hydrogen, so it means that lead is more reactive than hydrogen. I have copper, and then copper is more reactive than, I have tin is more reactive than copper. So the one which is on top is more reactive than the one which is on bottom. You understand? Therefore, the one which is on top is going to be oxidized, the one which is on bottom is going to be reduced. So that's how you identify which one goes to the cathode, which one goes to the anode. Then we go to this electrolytic cells. Electrolytic cells, chemical energy, electrical energy is converted into chemical energy. The other one is chemical energy is converted into electrical energy. That is a galvanic cell. But in electrolytic cells, electrical energy is converted into chemical energy. And then this one is very important in galvanizing the things, or electroplating. Which one do we put on the cathode? Which one do we put on the anode? Don't forget that. Use what you call red cut. Reduction at the cathode. And then anode, anox, which means that oxidation at the anode. So anode is the positive in here, and then cathode is the negative in here. So it's the reverse the other way. Anode is the negative and cathode is the positive. So in this case, oxidation, where oxidation occurs, the one which is reduced is where we put what you're gonna coat. You understand? So if you want to put what you see the negative, we put it on the cathode. You understand? If you put the spoon here, and then now the spoon, the anode is gonna start to deposit the substance. But this is now this is it has a salt bridge, is not a galvanic, is not electrolytic cell. Let me just look for you electrolytic cell here so that you understand what I'm saying. Yes, yeah, something like this. Yeah, so what you put here, for example, this is copper, this is copper. So now what, this is a positive, this is a negative. What you want to electroplate, it becomes at the cathode. You understand? And then what you want to electroplate with, it goes on the anode. Why? Because oxidation occurs at the anode. So the gold is supposed to be here, and then the spoon is supposed to be this side, so that now electrons can move from here to here. Here the concentration doesn't change, because what you form here, what you release here is what is being used here. So the concentration in most cases that isn't used. You don't go to without knowing also that why do we use a cheap an expensive element to coat the cheap element, so that you maximize the profit. You cannot use expensive versus expensive. Use gold and silver. No, you can't coat silver on gold. You see, it's like downgrading. So you have to look at something which is cheap, then you coat it with something which is expensive, so that it looks to be what? Expensive. Yes. I think what is electrolysis, and what is electrolytic. Electrolysis, and then what is electrolyte. Electrolyte is the substance which will undergo electrolysis. So electrolyte is it can even be a solid sometimes. Yes, a liquid. It can be a liquid, it can be a solid, it can be a gas. No, not a gas. It can be what? It can be in aqueous. Yes. So please make sure that at least, guys,